In this video, we're going to look at a pattern that you can use to memorize the coordinates of the terminal points of special angles. And here I've shown quadrant 1 with three special angles, pi over 6, pi over 4, pi over 3. And the thing that we're going to be focusing on is how you would find the coordinates for the terminal point, which is where your angle will intersect the unit circle. So we'll do that for each of these angles that are shown here. The first thing that we need to do is to establish a pattern that we can use so that finding the coordinates will be as simple as just counting from 0 to 4. And the pattern that we're going to have is that each of these coordinates is going to fit the form of the square root of 2, or the square root of some number divided by 2. Whether it's the x coordinate or the y coordinate, that will be true for each of these special angles. Once we have the pattern, we're going to fill these out by simply counting from 0 to 4. And for instance, I might start with trying to find the y coordinates. So I'll look on the unit circle where y is equal to 0. That's along the x-axis. Y is equal to 0 will correspond to this angle. So I'll start with 0 here, fill it in, and then I'll just count up from 0 to 1, 2, 3, and 4. Likewise, to get the x coordinates, I'll look for where x is equal to 0. That's here along the y-axis. So I'll start at 0 and count to 4. 0, 1, 2, 3, and 4. Now, when you look at these numbers, you're probably going to recognize that a lot of these can be simplified, and I'm not going to do that so much here, but as we go through some examples, you'll see how that works out. So, for example, the square root of 4 divided by 2. Well, square root of 4 is 2, so this is actually 2 over 2, or 1. And I would want to simplify that when I find this coordinate for the angle pi over 2. Once we've got the pattern down, we can start to think about how to extend this to quadrants 2, 3, or 4. And the thing that we're going to use is whenever you draw an angle, say in quadrant 2, you'll notice the reference angle here is equal to the reference angle here. I can use my knowledge about quadrant 1 angles to find the coordinates for quadrant 2 or even 3 and 4 angles. So what I'm going to do is I'm going to look at this angle in quadrant 1, and I'm just going to pretend that I know what the coordinates are of the terminal point. I'm going to say that these are A and B. And then I'm going to use symmetry on the circle to figure out the other coordinates in quadrant 2, 3, and 4. So the thing that I want you guys to notice right now is that when you go from quadrant 1 to quadrant 2, if the reference angle is the same, the y coordinate does not change. So the y coordinate over here is B, and that means in quadrant 2 it'll also be B. But when you go from quadrant 1 to quadrant 2, the x coordinate is going to change from positive to negative. So I'm going to have the same value A, except instead of being positive, I'll need a negative value. So my coordinates there would be minus A and positive B. When you go to quadrant 3, again we're going to have the same values A and B, but in this case both the x and the y coordinate need to be negative. So instead of positive A, positive B, I'll make these negative A, negative B. And finally in quadrant 4, again I'm going to use A and B. But then in quadrant 4 my x coordinate is positive, so I won't change my value of A, but my y coordinate needs to be negative. Instead of positive B, this needs to be negative B. So if I put these two things together, what we're going to do is graph a special angle in one of the quadrants, 2, 3, or 4. We're going to think about how to get those coordinates from quadrant 1, and then we're going to change the signs, positive and negative, depending on where the actual angle lives. So the next thing I want to do is a couple of examples to show how this is going to work. And the first one that I want to look at is going to be theta is equal to 2 pi over 3. First thing you always have to do for these problems is graph the angle. Theta equal 2 pi over 3 is a quadrant 2 angle that lives right about here. So I'm going to draw my angle. So there's theta. And then I want to stop and I want to think about what the reference angle is. So 2 pi over 3 takes me to here. Reference angle takes me back down to the x-axis. Reference angle here is pi over 3. And once I know the reference angle, I can think about what's going on in quadrant 1. So I'm going to think of those three special angles we have: pi over 6, pi over 4, pi over 3. Pi over 3 is the larger of the three, and then I can find the x and the y coordinate for that. So x coordinate, I want to think of where x is 0. That's right here. Count up to 4, 0, 1. My coordinate needs to be the square root of 1, which is just 1 over 2. To get the y coordinate, y is equal to 0 here. 0, 1, 2, 3. So my y coordinate is the square root of 3 over 2. So these are the coordinates for the reference angle, but what I'm really concerned about are the coordinates of the terminal point here for 2 pi over 3. And I'm going to use those same values, 1/2 square root of 3 over 2, but I need to remember that since this is a quadrant 2 angle, my x coordinate is negative, so I'll make that a negative. My y coordinate is positive, so I don't need to change this one. The next example that I want to look at is going to be 11 pi over 6. So theta is 11 pi over 6. Again, the first thing I need to do is to graph this, and let's see, it's a positive angle. So I'm going to start here and I'll go a half a revolution. That'll be 6 pi over 6. I'll need to go 5 pi over 6 farther, which will put me right about here. And when I draw this angle, it'll look something like this. Now my reference angle is going to be the angle that I need to get from the terminal side back to the x-axis. This would be a full revolution, 2 pi, which is 12 pi over 6. And if I've gone 11 pi over 6, 1 pi over 6 more would give me the reference angle, pi over 6. And then I can think about what this is going to look like in quadrant 1. Think about my three special angles. Pi over 6 is the smaller of the three. And then I can get the x and y coordinates for that. My x coordinate, I'm going to start where x is 0. Go 0, 1, 2, 3. So my coordinate is square root of 3 over 2. My y coordinate, starting at 0, go up to 1, I'll get the square root of 1 over 2, which is 1/2. And then I can come down here and fill up my coordinates. In this quadrant, it's quadrant 4, my x coordinate is positive, so I'm still going to have the square root of 3 over 2, but my y coordinate is negative, so I'll get minus 1/2. The last special angle that I want to look at is going to be minus pi over 3. Excuse me, minus 3 pi over 4. Theta is minus 3 pi over 4. And once again, I'm going to graph this. Minus 3/4 pi is going to be a quadrant 3 angle. It's going to go 3/4 of the way on the bottom half of the circle here. There's 3 pi over 4. And my reference angle will be the angle that I need to complete this half revolution. This was 3/4 pi. I have to go 1/4 pi more. So my reference angle is pi over 4. Once again, I'm going to think of quadrant 1, my three special angles. Pi over 4 is the medium-sized one. It's in the middle. And then to get my x and y coordinates, again, x is equal to 0. I'm going to count up 0, 1, 2. My x coordinate is square root of 2 over 2. My y coordinate, I'll start with y equals 0, 0, 1, 2, and get the square root of 2 over 2. When I take the information from quadrant 1 over to quadrant 3, I just need to remember that both x and y are negative here. So both of these coordinates will be minus the square root of 2 over 2.